Hello, everyone. We're back with another episode of I Build at 4 a.m. And for today's guest, we have Nader here, who is famous figure on the ecosystem. It's really good to have you here. Hello, Nader. How are you?
Hey, very good. Thank you for having me.
Oh, please. Thank you for coming, man. And first thing I would like to know is for people to get to know you a little bit better. I know you don't need lots of introductions, but talk a little bit about yourself.
Yeah, absolutely. I'm a developer for about 13 years now. I've worked in 4 main areas. I was a full stack developer. Then I focused on mobile for a few years. Then I worked at AWS for almost 4 years, focused on cloud. And then for the last 4 years, I've been in crypto and done a lot of open source. And I've gotten into education fairly early. So throughout my career, I've done a lot of different types of developer education, held meetups and conferences, and started coding schools. And now I'm doing developer relations and all types of stuff. So yeah, that's kind of about me.
So doing developer relations even before developer relations were a thing itself.
Yeah, pretty much.
I love that, pioneering the area. What about EigenLayer? What can you tell about it? It's, for me, I see it as so many possibilities of what you can build with it. I don't even know how to introduce it in a short way.
Well, for me, I can just say from my perspective, the reason that I was drawn to work here, not counting the founders who I really like, the way I kind of look at how developer platforms have evolved, there's a lot of things that kind of relate to how I feel the blockchain ecosystem has evolved for developers as well. So the way I look at it, you kind of had these early blockchains that were application specific, Bitcoin, Litecoin, Namecoin, etc. But if you wanted to build out your own application, you couldn't actually write any code and deploy it to those. So you essentially were either forking an existing blockchain or building it from the ground up. So the next big innovation that we had were smart contract blockchains or programmable blockchains. Ethereum was obviously the first one. Now we have dozens of these, Solana, and many others. So I kind of look at EigenLayer as kind of like the next evolution of that, not just EigenLayer, but maybe this whole paradigm of like restaking and shared security, in the sense that you can continue to have the same security that you would get from writing a smart contract on Ethereum or Solana or any other blockchain, but you're no longer bound by the constraints of a blockchain virtual machine. So you can actually do anything you would like, and you can write your logic in any programming language, but you can still have that security that you would expect without the constraints. And that's kind of the thing that really was exciting to me. And, when I joined, it was 2024. Started talking to them. I met Ethereum back in 2022, I believe. Mm-hmm. Kind of keeping up with what they've been doing, but I think it really clicked for me at the end of 2023 what they were building, and wanted to kind of be a part of that. So I reached out to Ethereum, and one thing led to another, and now I'm here. So it's been a year, and I've had a lot of fun, and we're just getting started.
That's the most important part, enjoying what you do. But how does it happen for Eigen to be able to create these environments where you can create a generalist application environment per se, where you can basically code anything with whatever resources that you want, and still having the security guarantees of a multi-decentralized system, right? Because Solidity, to make that, the EVM to do that, had to create lots of boundaries, like lack of some functionalities and even features that were always taken as granted in many developer environments.
Yes. So, I mean, the initial go-to-market for EigenLayer to get everything kicked off, it's kind of like this four-sided marketplace where you have stakers, operators, developers, and consumers. The initial kickoff was with the economic security, which was the stakers and the restakers. So essentially, you kind of have Ethereum now at hundreds of billions of dollars of economic security. Didn't happen overnight. Obviously, it happened over the course of like years and years. But if you wanted to build out a brand new service from the ground up that was not bound by a virtual machine like an Oracle or a coprocessor or really anything that needs security that you can't write into a smart contract. You would have to essentially build a network from the ground up, and you would kind of be starting from day one, meaning that you have to build the whole network of validators. You have to have a token. You have to have stakers if you're doing a proof of stake network, and on top of that, you have to still build your service and your product, and you have to do all the things that go along with that, running a business and marketing and all that. So with EigenLayer, essentially, we remove a large portion of that work by just giving you this pooled security that you can apply to whatever application that you'd like to build.
Mm-hmm. So it's all about how you can actually guarantee the security through the slashing mechanisms and the restaking features, right?
That's exactly right, yeah.
Is this what forms an AVS specifically? Like, what is the concept of an AVS? How does it fit all the Eigen narrative?
Yeah, so we have all this security, and it's essentially part of the EigenLayer protocol now. That's where we hold the stake. It's within our contracts. And then you as an AVS developer can kind of like write your off-chain, all of your application essentially using off-chain logic. And then you can kind of use our smart contracts for the verification, which ultimately will be where you have some type of slashing mechanism for any situation that you would also probably see slashing in any other protocol. And that's kind of where we are today. We have slashing on testnet, and the final piece is slashing on mainnet, which is coming within the next 60 days or so.
What about how do you, so something I didn't quite understand while researching the general structure of AVSs, it's how do you decide when you have to slash someone? How do you guarantee that that specific computation was performed in an honest or in a malicious way?
That's a good question. Yeah, so there are kind of like two main types of slashing. And I would say, really there's two main types. You have objective and you have intersubjective. And objective is what we're kind of used to. It's something that you can prove on chain, and it's much simpler than intersubjective. So you can kind of say, okay, based on the block information here, I can tell you that this transfer should have been allowed or should not have been allowed, or this financial transaction is actually something that should have been allowed or not allowed. And therefore you can do the slashing based on just information you have on chain. The challenging part is the intersubjective slashing, and that's when you do have to kind of really go out of your way to write custom functionality based on what you've built. So an example of what intersubjective slashing would be applied to would be something like an Oracle, where you're taking information from the real world and bringing it on chain. So a good example of how this is used in practice is like Polymarket, or obviously any other Oracle that you kind of might thinking of like US dollars brought, the value of a US dollar, right, brought on chain. So those sorts of situations are more complicated. So yeah, I think like what we have with V1 of slashing allows developers to build that logic. It's still a little challenging. What we have coming up soon after, though, is actually going to be like an order of magnitude improvement for intersubjective slashing as well. So I think, it's kind of like an evolution. We have a lot of people building intersubjective slashing already, but it's just going to be a lot easier because it is challenging at the moment to write that logic.
So for intersubjective slashing, you need some complex decision that is related to the application itself, what I understand, right?
Yes.
So depending on what you're building, you need to create some fault proof that's different based on each.
Exactly. Yeah. And then when you think about how challenging this kind of is, you can kind of look at some of the protocols that we have, that people use every day, like Solana, that still don't have slashing implemented because of how challenging it is, right? So this is not like an easy, thing to have. And we've also taken our time to make sure that it's done correctly. And yeah, I think, things like that do take time, and they are challenging, but it's something that we've thought. When I say we, I'm the collective we. It's because all the smart people that actually did all this work aren't here with us today. But something that our team has been thinking about for 4 years. So what they have coming over the next 3 to 6 months will be really interesting and really great. And I think that the AVS developers will like really appreciate the time spent to kind of figure all this stuff out.
Right. One other question that I would like to ask you regarding AVS still is, how do you think it compares to Rollups, for example, in a way? It's kind of a scaling way, a way to scale your applications, right? Execution environments.
Yeah. Before we dive into that, I want to actually just touch on like what intersubjective means real quick. And I think most people probably know this already, but in case you're not familiar with this, it's just intersubjective is essentially like a decision or an answer that can be given that everyone essentially pretty much agrees with, that you can't prove with the environment that you're in. Like for instance, in our case, a blockchain environment that has certain limited amount of information that we can work with. So an intersubjective question would be, who is the president of the United States today? We can pretty much all agree on that. A subjective opinion would be like, what's the best city in the world to live in? Those are the sorts of things you can't really obviously prove, because there is no right answer. So anyway, so you have like objective, subjective, and intersubjective, and with EigenLayer you can build applications based on objective and intersubjective information. Okay, now going back to your next question, what was the question again? Because I kind of got off track. Oh yeah, you were asking about rollups.
Yeah,
rollups are interesting in this context, because they are kind of like an evolution of scalability that are beyond the I would say general blockchains that are kind of like general purpose blockchains like Solana and Ethereum, for example, because we're given a programming environment that we can work with, but we can't move outside of the constraints of that of that programming environment, right? So with rollups, yeah, you have now people building application-specific rollups where they're adding their own custom functionality that kind of help them move beyond that. But that's still a somewhat heavy lift, but it is also still somewhat, I would say, restrictive in like what you can do within that virtual machine. So I think like the evolution could even be application-specific blockchains, programmable blockchains, rollups, and then something like EigenLayer. So that's a really good question.
So I really like that we were able to experiment a lot with the potential of Eigen, and I was really amazed of lots of things that we could build. We're gonna enter that later about when we talk about the experiment week that we just had. But I want to get like your insights on general things that you can build with Eigen, right? What is the objective? What are your dream applications? What do you want to see there?
Yeah, totally. So the cool thing that for me is working at EigenLayer that we can do, it's that there isn't really a limitation about what you can build. And it reminds me a lot of my time at AWS and what drew me there. I really have always been interested in like developer tooling and developer platforms. And for me, before working at AWS, that was like open source, because I could create some software, I could open source it, and anyone could use it and build whatever they want with it. And it was always a lot of fun. And I was also using other people's open source, obviously. And it was just really, really interesting to me. It blew my mind when I first learned about open source, because it's been that long. Like back in the day, this was kind of like a new thing for us, right? So when I learned that someone would spend like a year writing code and then make it available for me for free, I just didn't get that. I was like, why would they do that? Like, why wouldn't they just charge for it or something? So that was like a really big thing for me, and it really was exciting. So with AWS, it was really exciting also because you had hundreds of different like services that people could use, and they could build anything they would like. And they were able to remove like a lot of the work that they would need to have done otherwise. So if they wanted to build out an application, they could focus on just the application, and they didn't have to worry about building and running and managing all the infrastructure. At AWS, we used to call that undifferentiated heavy lifting. So it was kind of like the value proposition of building on the cloud. It's that you didn't have to worry about all of this work that didn't differentiate your application or your company or product, and therefore you could move quicker and you could innovate faster. So you didn't have to deal with the database maintenance and uptime and server management and all that stuff. It just auto scaled for you, and everything was good.
Yeah.
So Yeah, that's kind of the analogy that I have with EigenLayer, and in the sense of you have this developer platform. I think the main difference I made a video yesterday kind of just trying to summarize EigenLayer for developers for ETH Denver, because we have so much going on and so many people come and ask us questions. I was like, let me just put as much information into a video, and then I can share this video anytime anyone asks. But the analogy that I had there was like AWS is a platform where you can use all these different services. With EigenLayer, we have a similar platform, but anyone can go and also build a service that anyone can then use. So it's kind of like an open source AWS for blockchains, where anyone can go and build a service, anyone can use it. And unlike just a blockchain, you can build anything at all. So some of the categories that you were asking about, like that excite me. I think we have like coprocessors, roll-up services, cryptography, proofs. Like we have these different verticals, but a lot of the things within those verticals kind of, expand outside of the verticals. But
and they mesh up between each other
exactly,
as well,
yeah,
right?
Yeah. So it's kind of hard to just to categorize things, because we have like a lot of AI services being built, data collection, data generation, data attribution, even data availability is used in some of these AI services. You have verifiable inference, data storage, long-term and short-term storage. You have model marketplaces. You could even bucket trusted execution environments into a lot of this stuff. I think proof of location is kind of interesting. We have a company called Witness Chain building proof of location, where you can essentially prove where a photo was taken, or you can prove where a validator is located. Like if you want to have true decentralization, there's like a lot of interesting use cases there. Proof of machinehood, like there's this category of proofs. Oracles, I think oracles are just still somewhat of an untapped like area, even though we already are very familiar with like Chainlink and a lot of these other oracles. But I think when you remove the barrier to entry for people building arbitrary oracles, then you can really build all types of cool stuff on chain with off-chain information from the real world. And a poly market, to me, is like a really great example of something that from the first look, you imagine this to be like this gambling marketplace where people are just like, it's another casino. But in reality, what was drawn from that was the most accurate news source in the world ever. And I thought that was actually the real interesting use case of something like Polymarket and prediction markets, is that you're able to draw truth much faster than you can otherwise. So if anyone can build those sorts of things and just make that barrier to entry to build oracles lower, then you now open the door to a lot of innovation. And if you want Chainlink to support a certain thing, it's this massive lift. Like it literally is almost impossible for the average person to do anything there, because it costs millions of dollars and it's like a lot of engineering, right? But if anyone can essentially write maybe a few hundred lines of code and bring some information off chain and have it available on chain, then that's just like a 0 to 1 type of innovation again. So yeah, I mentioned a bunch of stuff, but those are some of the things that are kind of exciting to me.
Yeah, I mean, there is a lot of integrating between real world, Web 2, Web 3, everything connecting. I love it. Do you think you can show us graphically somehow with some drawings or charts, like how all of it happens in the background?
Yeah, totally. I think the most, I've tried to dumb this down. I'll show you a couple of diagrams that we have. I'll show you the one that we have in our documentation, and then I'll show you one that I drew from our documentation. So I'm going to zoom in a little bit. So this is the, if you go to the EigenLayer docs and you go to developers, go to overview, we have this diagram here where you have the on-chain component and then you have the off-chain component. And the on-chain component is where you actually have your AVS, which AVS is an acronym for Autonomous Verifiable Services. And this is your on-chain logic for your service. You deploy your AVS contracts to EigenLayer, and then your off-chain service interacts with your AVS contracts. And then 99% of your code is actually written over here off-chain. Mm-hmm. And that's exciting and fun because you can do whatever you want off-chain, right? You can import libraries, you can make HTTP requests, you can do really whatever you want. and you can do it in whatever programming language that you want. The consumer then interacts with the off-chain component, and then that's kind of the traditional API model that you might be used to. And then I'm going to share one more diagram that might also be something. Let's see here. That might be even a more dumbed down version of that. Okay. So I tried to make a more simplified version of that, even that's more using like Web 2 language, like API calls and verification. So we have like the off-chain API. We have the user over here. Mm-hmm. She's making API calls to this app. And then we just have like this verification mechanism happening that takes whatever is happening here and uses the AVS smart contracts. So we currently have SDKs that try to make it a little easier to write your, I would say, to interact with your AVS contracts in Rust and Go. But you can really use anything. We have a Hello World that's really popular. It's written in TypeScript. We have a lot of Python developers. So yeah, that's kind of the general idea.
How does this communication between the off-chain and the on-chain happen? How does the message passing works in there?
So you can decide how that is done, really. So there's typically an aggregator, and you can use ECDSA signatures, or you can do BLS signature aggregation, and therefore you have some type of consensus around the operators, and then you can kind of use that to be your consensus, I would say.
That's so nice, because this really throws back to the comparison you did between AWS and Eigen, and being this super empowered provider of services, right? To anyone who actually wants to create something new, to create something different. And how does all these solutions integrate with the AVS, with other solutions from Eigen? I mean, EigenDA, for example, is something that I've been seeing a lot while navigating through your website, documentation. What other components do you think are worth mentioning?
So we do have some teams, I would say, that are using multiple AVSs or where they're complementary. EigenDA specifically, we have the original use case was essentially data availability for rollups, which is still by far the main use case. We have really great companies working with us that are using EigenDA, like Avo, like Mantle, like MegaETH, and Celo. But we're also seeing people use it for, like, I would say, temporary storage. So contextual storage for LLMs is actually a pretty popular use case now, where you want to have like some context that you're feeding back into the LLM for multiple calls back to back. And you don't really need it to be around like a month later. You just need it like temporarily. So yeah, that's the whole idea with EigenDA, with data availability. It's not data storage, like permanent storage. It's more like temporary. But yeah, that's one thing. But I would really say, for the most part, like most of the consuming applications are only using like one or two AVSs. But I would also call out that it's been less than a year since EigenLayer has been to mainnet. The slashing mechanism isn't even on mainnet yet. So you could almost look at the EigenLayer ecosystem as still fairly immature relative to where it would probably be another year from now. We have, 100 plus really what I would call like blue chip type of companies building on EigenLayer already, but a lot of these AVSs aren't to mainnet quite yet. Mm-hmm. And we have really interesting things built like building with Polymarket and UMA protocol, just really like announced a couple of days ago. Some cool. So there's like a lot of cool stuff that isn't quite live yet. So I think like the number of services right now is still fairly small. So therefore, we're not really sure what it's going to look like a year from now when we have hundreds of services available, like how people are going to consume those from the consumer side.
Nice. Another topic I wanted to touch up on is the Cartesi plus EigenLayer experiment week that we just had. which was awesome. We created this integration, right, between Cartesi and Eigen. So it's called the coprocessor. And what you can do with it is you can run the Cartesi machine as the execution environment inside Eigen. For now, it's as simple as that, communicating through smart contracts. But we could even in the future integrate to our fraud-proof systems that, correct me if I'm wrong, I might be, but using these fraud-proof systems, you would kind of turn the intersubjective and the subjective that you mentioned into something more objective, right? Because then you can actually verify what is the correct expectation for that computation.
I think that's a good way to put it. Yeah.
Yeah. But were there anything that you found interesting in the solutions that were built, or the coprocessor infrastructure as a whole? What were your thoughts, general thoughts on the experiment?
Well, yeah, I just thought the quality of the experiments were really, really great. Actually, there were a few that really blew my mind. And I feel like the quality of developers in the Cartesi ecosystem was really, really, really good. So that was really interesting. And you never really know what people are going to build when you give them new tools and new like possibilities. So it's always fun to kind of see that. But yeah, I thought the outcome was really, really great. I was one of the judges, and I don't remember all of the exact projects at this point, but there were some really there were a handful that really stood out to me. But overall, they were like in general really good.
I've been playing a lot the Pokemon Battle Simulator that a guy created.
Yeah, that was crazy.
That was pretty fun. And the other one which I liked a lot was running all the machine learning models verifiably on chain. That for me was a little crazy. Mm-hmm. Still a lot of room for improvement, but I found it really, really nice, man.
Yeah, I mean, because the amount of time spent for building all those was also pretty small. The fact that they were able to do so much, it's really cool.
1 week. Yeah. 1 week with a lot of sweating and people going crazy on Discord, but it's worth it.
That's how it is with these hackathons.
Yeah, I mean, you constantly judge hackathons, right?
Yeah, quite often.
That's so nice, man. What about your general views on where the Web3 ecosystem, the state of Web3 is right now, what you're looking forward to?
You know, it's interesting because like when you're working here day to day, it almost feels like things are moving extremely fast and extremely slow at the same time sometimes. But when you kind of take a step back, you do see that things have come quite a long way. So I think that obviously where we are today is better than where we were yesterday, and then where we are today is much better than where we are a year from today. So things are progressing. Ultimately, it's about like UX and scalability, and I think that we've started to see some really, really great UX with a lot of the account abstraction and a lot of the newer wallets and a lot of the just experiences being rethought from the user perspective. I think where we're at now is the scalability is starting to also be, so the UX to me, I wouldn't say it's solved, but we do understand like how to solve it, and it is being solved. And even some of the applications today that I've used, I would even say would go as far as to say that they've kind of solved a lot of it, right? But in terms of the scalability, that's where we're still, kind of moving a little slower than when I first joined, I would have kind of expected. But understanding the constraints, it makes sense, right? Like we're trying to compete with DynamoDB, which, can handle up to 100, at least with my experience at AWS, Amazon Prime. I forgot the name of that day, but like, the Prime Day, I guess, they handle like 100 million operations per second. And that's orders of magnitude more than like anything we have in Web3, not even close, right? Like we can't even really even compare the two. So I think the optimistic type of architectures like EigenLayer actually help enable those sorts of things, because you're not bound by the peer-to-peer networking and consensus constraints, but you're still able to kind of have those security and verifiability characteristics that you need. So we're starting to get there. It's really interesting to kind of be a part of that, and the fun thing about working in Web3 is that these questions aren't really answered yet, and the problems aren't solved. Because if they were, it'd be kind of boring, right? So,
I do think there are some bottlenecks that have been lately, at least, so hard to tackle, so hard to like crush. I always think throughput is something that, at the same time we develop, we evolve, we move away from. So like when we say, okay, now let's start ZK proving everything, then we move away from our throughput capacity. So it's always a battle between like being able to manage scalability and the levels of decentralization, security, and what's cool that people want to release as soon as possible. Have you seen discussions in Interop? I've seen so many discussions in Interop that I really feel like AVSs are a great solution for that, because instead of going crazy with rollups, you can simply use the base layer and have fast finality and use lashing as a mechanism for defense.
There's so many interesting things happening there, and there's a lot of techniques and approaches. And yeah, I think we're getting there. You have what you mentioned. You have the typical like bridging mechanisms. You have like the intents and all these different techniques and approaches that are essentially just trying to solve the same problem. And we have just a lot of companies that are also working with us, and obviously there's really great companies that aren't working with us as well. And I think like everyone pushing this type of innovation forward is great. Some of the teams that I've worked with, Hyperlane, Omni, we have Layer 0 and DVNs and stuff like that. So yeah, I think we're going to have a lot of great options, and may the best man win.
That's really nice. Here's the thing. In here, we always like to play a little game, which is called Rapid Fire Chat, which I propose some quick questions to you. You don't think too much, and you just reply them.
Cool.
And can we try that?
Let's do it.
Okay. So give me one person that really inspires you in Web3.
I want to say my boss, but I'm not going to do that because that would be cheating, and I want to try something different.
You can say that.
I can tell you it's Georgios from Paradigm.
That's really nice. And what about a person that inspires you from outside of Web3?
There's definitely a lot of people there, and I know this is supposed to be rapid fire. I think Guillermo Roch is the founder of Vercel. He's definitely inspiring.
That's really nice. As a DevRel, you definitely went to many events and talked to many people. What was your favorite event in your life?
It might have been DevCon Bogota.
DevCon Bogota. Okay, 2 years ago.
Yeah, it was my first DevCon, and it was my first time to Colombia. It was just a really, really fun experience.
Someone you would really like to code with, to hack with?
Georgios from Paradigm.
What about your favorite book?
It's called No Death, No Fear. It's basically a short, I guess you could say, Buddhist philosophy type of book written by Thich Nhat Hanh, who's this like English-speaking Buddhist monk who's really awesome. So
this was really nice. This was a really fast one. You had this on the back of your head.
Definitely something I know for sure.
That's a really nice one, man. Yeah, I love these rapid fire sessions to get a good insight on how the person replies with little time. But yeah, I think that's a wrap on what I had prepared for today. Do you have any other topics you want to discuss? Any message you want to send out there?
No, I don't think so. This was really great. I appreciate you inviting me on, and I enjoyed the conversation.
Thank you so much for coming, man. I hope we get to do this again a short while. And yeah, I think I see you in Denver. Are you going there?
I'll be there.
Oh, that's nice. So let's grab a beer. Let's have a chat.
Let's do it, man.
Okay, thank you so much for coming again. And that's it. That was a Builder 4 AM. Keep building and pioneering the world of Web3. Bye-bye.